For learning analytics, my project was document profiling. I'm going to demonstrate how to use the outcome of my project. Um, so this is the repository of data, or of my code, sorry. Um, I have two batch files which you can run. One is to scrape content from your browser history and from, I believe, Lifehacker, and then the other one is to perform the document profiling based off of the data that you've scraped. So after you scrape data, it'll populate itself in the data folder, um, and then the script will pull data from the temporary files in there and export um, kind of recommendations for your history. So if we start it, you can see I just run scrape and it will start scraping from Gizmodo and from your browser history. Gizmodo scraping is pretty straightforward. It will request from their website and scrape pages. Right now I've got it set to scrape about 500 articles, I believe. And then the browser history is slightly more complex. You have to get an authorization token from Google, um, which they don't really hand out unless you're the browser. So basically what I did is I took the authentication token that your browser has to enter into your Google history and use that to request from their API. Otherwise, you'd get a 403 HTTP status code and you wouldn't get any data. So here it is scraping the actual history. Um, First, it scrapes the URLs and then it goes and actually scrapes the pages for their content. For my project, I decided to use your browser history. So I scraped your browser history, created a user profile using the methods outlined in class, and then I used that to recommend a document from Gizmodo's pages. So if we go to the data folder right now, we'll see that we have our temporary files. Mostly they're just simply CSV, JSON, and SQLite database files. Now if we go back to our script, we can run our script, and basically what it's going to do is it will generate scripts for the user, or sorry, CSV files for the user um, profiles, and then it'll go through and do the document profiling computation. So this is the first document, and it's just going to do all 5 based off of some different criteria. So while that goes, I will go and show you the different criteria. If we open up the script, you can see that the default is it'll just grab whatever is from your user history. The second user profile I have is it'll scrape up until this time. And you can specify whatever time you like and format. And then you can also do keyword-based user profiles. So I did one for sports, one for programming, and one for foodies. And you just provide keywords that you want to filter that to make sure that your article has at least one of these. So you'll see that an article will contain at least football, baseball, soccer, rugby. Um, and you'll see that these generate all different document profile information. And so here's the actual profile computation being outlined in this, or being performed by that Python script. So if we go back here, I can scroll up, and so we have recommendations from normal browser history, and then I just had the top 5 um, closest matching documents based on our user profile. So it's recommending that we read how to start fresh again on social media. We scroll down, we'll have from the certain date, because the date is only like 11 hour at 11 o'clock, sorry. It's pretty much the same. The problem here is that I didn't have enough uh, data to compute against. I only had about 600 records of browser history and 600 records of documents from Gizmodo. And I would have used more, however, for demo purposes, the computation takes far too long. Um, there's certainly some optimization that I could perform, but at this time I am not interested because I have I have a limited time frame. So here you can see with the keywords we actually do get different recommendations. So I worked at bar security, and here's how to talk your way out of a bar fight. Um, things like please stop man threading and what to expect from Laurel Lance's mysterious return. I'm imagining that's on the TV show Arrow. And then so for programmers, they go into things like Evernote, which is an app, and PlayStation 4, and the best iOS camera. So more tech related articles. You can see how document profiling does a better job of kind of giving things in your wheelhouse, but based on my implementation, it hasn't exactly narrowed it down perfectly well. And you'd see that if I had, for example, taken a document that was exactly the same, you'd get a cosine similarity of 1, whereas these are, you know, 0.2. So they're not exactly that similar. And the problem with that is um, the document source that I have is your browser history, and I'm taking the entire web page and taking all of the text from that and using that as the word vectors for our computation. So I haven't actually seen a cosine similarity of zero point 0.3, anything above 0.3, and that's because there's just um, such a large set of words in our word vectors. So if I had taken, for example, just your history from Gizmodo and I'd compared it with articles from Gizmodo, then I would expect to see a higher cosine similarity. Um, yeah, and then the last one is gamers. So tech deals, movies, Evernote again, Place in Michigan, and here you can see that these two again are repeated. Goes back to not having enough data to compete against. Um, but there we have it. There is our demo of code, and if I briefly go over the files involved, I have the Gawker scraper folder, the history scraper folder, the profiler, and the user builder. And so they're kind of self-explanatory. This scrapes Gawker websites. This scrapes your browser history. The user builder builds the um, kind of the user profiles. Excel's having problems opening large files. Here you can see got the URLs, post time, the data, and that gets put into our profiler. Um, and then the profiler will, excuse me, the profiler will create our document profiles, and we create our word vectors. We filter out non-alphanumeric characters, and we split the string up into two individual words in an array, and we strip out really common words like is and it and that sort of thing. And then we stem words such as stopping would become stop, that sort of thing. Thank you.